let's see. Everything you do in Math 60 is really important. Have you noticed that everything you're learning leads to the next idea? Well, this problem set right here is perhaps the most important idea in the whole course, where we're going to talk about how to use the distributive law to help you factor. And factoring is a concept we're going to use a lot, especially in Chapter 2. You've already learned the distributive law. It says that when a number multiplies a sum, then it has to multiply each term. One question would be, well, why do you even need it? Why don't you just follow the order of operations? The answer is, well, what if you don't have like terms here? Well, what if you can't add these together? Then this is the only way that you could do it. So there are times when you have to use the distributive law. And what you've done earlier is you're taking if the expression is written as a product, right? Isn't that what this is? The product of two factors? And you use the distributive law and write it in additive form, you're multiplying it. This is additive form, it's the sum of two terms. It's really important that you understand the form of this. This is a product, this is a sum. And when you go from product form to additive form, you're multiplying it. Okay, so the question I was looking at before is, when do you have to use the distributive law? On the first one, you don't have to use the distributive law, right? It's just going to be negative 10xy. But on the second one, you do. You have to multiply each term by negative 5x. And it's because these are not like terms. The only way you could multiply it out is with the distributive law. So there's more than one way to multiply, right? That's what I'm saying. Well, it turns out there's more than one way to factor as well. Factoring means to write it as a product, to write the expression in product form. In this class, you're just going to learn two ways to factor. You've already learned one way with primes. Today we're going to learn how to use the distributive law to factor. And when you get to take Math 80 and Math 90, you'll learn about 6 or 7 other ways to factor. But the key idea is always remember the definition. When you factor something, you're writing it in product form. So visually, you're given an expression in this form, additive form, and you're writing it in product form. When you do that, taking an expression and writing it in product form, what you're doing is factoring, okay? So let's look at these two problems. Just as we were saying before, there's more than one way to multiply, there's more than one way to factor. On this first one, you would just use primes, and you could write it as 6, it says factor completely, so 6 times 4 times x, and then the final answer would be 2 times 3 times 2 times 2 times x. But you can't just factor this into primes. This is the sum of two terms. What you would have to do here is use the distributive law. You're trying to find, see, you're written in additive form, you're trying to find this number a. This is called the greatest common factor. Try to find this number a that's multiplying each term, and when you find it, you can pull it out front. So what is the number that's multiplying each term? What is the biggest number? The answer is it's 2, isn't it? That 2 can be pulled out in front of the parentheses over here. Now all you have to ask yourself is, what's left? What do you multiply 2 by to get 4x? What has to go right here? The answer is 2x. You multiply 2 by 2x, that'll give you 4x. Plus, what do you multiply 2 by to get 10? 5. So this would be written in factored form because it's written as a product, you see? 2 times the quantity 2x plus 5. That's how it works. Let's just do a bunch more. All right, so on all these problems, we're using the distributive law to factor out the greatest common factor, 9y plus negative 6. What is the greatest common factor? What is the biggest number that goes into 9y and also goes into negative 6? The answer is, it's 3. 3 is the greatest common factor, right? Okay, so what do you have to multiply 3 by to get 9y? The answer is 3y. Plus, what do you have to multiply 3 by to get negative 6? The answer is negative 2. This is factored because it's written as a product. So how would you check yourself? You know how you would check yourself to see if you did it right? If you multiply it back through using the distributive law, you should get what you started with, you see? Anyway. See, when you multiply, you're going from product form to additive form. When you factor, you're going from additive form to product form. So if you factor, then multiply, you go back to where you started. Interesting, huh? All right, let's do some more. Factor this completely. Let's see. What is the biggest number that goes into 12y and 6x? How about 2? How about 3? How about 6? 6 is the greatest common factor. Always take the biggest out, okay? So you take the 6 out. Now the question becomes, okay, what's left inside the parentheses? 6 times what equals 12y? The answer is 2y. And then the next question is 6 times what is 6x? It has to be an x. So this would be considered factored using the distributive law. Okay, a couple more, then I'll give you some to practice. It might be hard at first if you're not used to doing this, but if you practice, you'll get really good at it. All right, now if you have 3 terms and you want to factor, first of all, why isn't this already factored? Why isn't this considered factored? It's not factored because it's not written as a product, it's written as a sum, right? You're going to have to figure out the greatest common factor of all 3 terms, and it's 4. 4 is the biggest number that goes into all of them. X is not the greatest common factor because it doesn't go into this one. What do you multiply 4 by to get 12xy? The answer is 3xy. What do you multiply 4 by to get 8x? You get 2x. What do you multiply 4 by to get negative 20y? You get 5y. Remember, when you take it out front, you have to take it out of each of these terms, right? It has to disappear from each of them. Okay, let's do another one here. This one, what is the greatest common factor here? What is the biggest number that goes into both of these? Well, let's see, 4? Well, how about 4x? 4x is actually, x goes into both of them, right? What do you multiply 4x by to get 4x? The answer is 1. Don't forget that 1 there, that's really important. What do you multiply 4x by to get 8xy? The answer is 2y. This is considered factored because it's written as a product. Okay, a couple more, then I'll give you some to practice. Now here, the greatest common factor, you're trying to factor using the distributive law, the greatest common factor is the biggest number that goes into both. Let's see, 3? I'm going to go with negative 3. Negative 3 is actually another option. Typically, if each term is negative, I like to take the negative out, but 3 would be okay. What do you multiply negative 3 by to get negative 3x? There's still an x left. What do you multiply negative 3 by to get negative 6y? You'd have to have a 2y. So this is considered factored because it's written as a product. Okay, one more, then I'll give you some to practice here. This one, even though the problem just says to factor completely, if you can combine like terms, always do it. Because that's just one of those things you should always look for. Even if it doesn't tell you to do it, combine like terms first. Now what is the greatest common factor? Greatest common factor is 3. So it'd be 3, and then you have to multiply 3 by 3a to get 9a, and then a 5 to get 15. This is factored because it's written as a product, right? All right, so go ahead. Why don't you hit the pause button, try these, and we'll go over them in just a minute. Okay, here are the answers. Let's see, on that first one, let's see, 6x plus 10, the greatest common factor is 2. What do you multiply 2 by to get 6x? You'd have to have a 3x plus 5 inside the parentheses. Now hold on just a second here. Tell me what's wrong with this. What if you went like this? 3 times 2 times x plus 2 times 5. Why wouldn't that be considered factored? You know why? You know why that's wrong? What does it mean to factor again? To factor means to write in product form. Would you call this product form? No, this isn't factored. This is still written as additive form. You see, this is a term, this is a term. So this is not factored. To factor means to write as a product. So you have to use the distributive law here. Okay, the greatest common factor on the second one is 5. So inside the parentheses, you get 6sp plus negative 3s plus 4p. The next one, the greatest common factor is 7. Now here, this is important. When you take the 7 out, don't forget to put the 1 here. There's a 1 left right there. Otherwise, it wouldn't multiply to give you the right answer. This one's pretty sneaky. Before you use the distributive law, look to combine like terms. These are actually like terms. This is sneaky because we wrote the variables in a different order, but these are like terms. So then you combine these like terms to get negative 4xy, but look, this is one term. You do not need to use the distributive law here. You just factor into primes, you see? So you always look to combine, and that's the reason. This one, you'd take a 2x out. If you just took a 2 out, it would be marked off a little bit. And this last one, there is no common factor. See? There's no number that goes in all of them except 1. So you could write as 1 times this, or you could also say can't be factored. Either one's fine. All right, well, keep working on this. I know this might be hard for some people, but just keep working on it because this is going to be used a lot for almost the whole rest of the quarter. Okay, you can get it if you keep trying. All right, good luck. Bye.